Hi, in this video I'm gonna use the experiment manager to do reinforcement learning. This is a tool that can also be used for deep learning. I'm gonna put a reference to a deep learning example for using it, but the key idea is basically that you have a set of parameters, hyperparameters, that you want to tune and find out which combination is better. In this case, we're gonna train the agent and also the environment separately. So for the case of the agent, we have some learning rates parameters, which are hyperparameters. I'm gonna try two values and some discount factor for the reward. And basically we're gonna try all the combinations, which is 2 to the 3, which will be 8 combinations. And since they are very small, we're gonna do exhaustive sweep. But you also have Bayesian optimization, if in the case that you cannot do an exhaustive search. And also we're gonna do something similar for the environment, but in the case of the environment, we're gonna use the rewards for the environment, and the environment is gonna be the water tank example that I'm gonna put the reference in the description for the water tank. I'm gonna, in that video, I'll talk a little bit more in detail, but in summary, it's basically a Simulink model in which you have a water tank and you want to control the flow of the tank so that the tank gets into a desired height. So it has an initial height and you want to take it to a target height, and that could imply either draining the tank or filling the tank, depending if the target height is smaller or bigger than the current height. So yeah, so the reward basically is to fill the tank, and also you get a penalty for getting out of bounds. So those are the training the weight, I mean the reward that you play with environment. Okay, so we're gonna see both of them. So let's start this example first, copying the command, and we're gonna go to the MATLAB desktop. I already have the example open. That's gonna take you to this place, and this is the command to open the project. And the project has a series of scripts for initialization, and we're gonna see them in a moment. Okay, it finished loading, so it started the experiment manager automatically, and you can see that we have a pair of scripts. One of them loads the final time and sample time into the workspace, and the other one is gonna do the startup and uses this weird command for starting the experiment manager. But the experiment manager can be also started with this command, as you can see. So let's see the agent first. The parameterization on the experiment manager for the agent. So we have the learning rate, one learning rate bigger than the other one. So the same goes for the critic, and also the non-unitary discount factor. And we're going to try the 8 possibilities. But you also have to provide a script, and this script is gonna do the actual reinforcement learnings, the creation of the agents, and also the training. So it's gonna take the parameters that are given here, and also it's gonna, let's take a look by clicking edit, and you can see that it takes as input. This script takes as input. This could be an M script, but they use an MATLAB in here. So it takes the parameters, which is the one that you're trying the 8 different combinations, and the monitor is basically for creating a data logger, because the experiment manager is in control of the log, so you have to provide a logger into a training. And for the parameters, well, we're gonna use the water tank. As I mentioned, this water tank example is explained in a video that I place in the description of this video. You go below the video and you're gonna see the description, and you're gonna see a link to that particular video explaining this in more detail. So basically it's what I described earlier, where you're trying to fill the tank and control the flow through the agent. So this is the model for it, and you can see the agent in here. So you're gonna evaluate in the base, get basically the final time and sample time from the workspace, and you're gonna put it into a base workspace, and you're gonna create an action, information about the action. The action is a flow, so it's a contiguous scalar, and whose values can be from negative infinity to infinity. And the observations is a vector of 3, and as I mentioned in the linked video, it's gonna be for the accumulated error and height can be from 0 to infinity, and the other ones can be from negative infinity to infinity. So you got the observation info, the action info, and the block. You have to pass the block of the agent. You're creating the environment in here. with the model and the agent. So you have to, the environment needs to know who is the agent. So that's why you pass the block. So the reset function is pretty simple in this example. It's basically like in the link example, it's the same thing. You're gonna randomly set the initial height and the target, the reference height. This is the reference height. You don't want it to go out of bounds, so you clamp it in here and you get the block, and from the block you set the height, and that's gonna correspond to this block in here. This is the desired water level, and the height is gonna be the you're gonna have an accumulator in here. So this is the water accumulated and this is the flow. So basically initial height is gonna be this initial condition in here. So that's basically what you're setting into there. You can see that this age and the water tanks correspond to this path in here, and you set the random initial height of the water tank. So that's pretty simple, and basically you just pass that function as a handle to the reset function. And for the agent option, this is where it gets interesting in this experiment. So you have some mini batch size, regular parameters for the agent options, but the ones that you want to control is the learning rate for the actor and critic, and you take it from the object that is coming from the experiment manager. So this is how the experiment manager is going to play with this, and also the discount factor for the reward. Okay. So yeah, the reason why it's non-unitary the discount factor is that you want to discount the reward to put pressure on the agent to finish the task faster, because if you get the same reward always, regardless of the time passed, then the agent is not going to be in a rush, and by putting in the experiment manager as 0.99, you put it in a little bit of a rush, the agent. Okay. So you're going to use this local function, which is to create the agent and the critic. Both are going to be neural networks, so they're pretty simple neural networks. The input for the critic is going to predict with a Q value. It's going to predict the expected reward for the agent from the current time until the end of the episode. So the inputs are going to be observation, which is the vector of 3 values that I just mentioned, and the action. So both of them are going to go through a set of fully connected layers along with some relus along the way, and they're going to be added, they're going to be merged. The video that I placed show more details about this, but it's a regular neural network, and at the end the output is going to be the reward, the Q value, and then you create the critic network, you pass the observation information and the action, which we already created, and then you get the critic using the RL Q value function. It's going to be a Q value to predict the predicted accumulated reward. For the actor is simpler. Also uses fully connected layers, but the input is the observation and the output is just the flow for the network. So you also convert it into a DL network, pass the observation action, and using the contiguous deterministic actor, create the actor. It's continuous deterministic because it's flow. It's the flow of water, so that's going to be contiguous. So with the actor and agent, now you can create your deep deterministic policy gradient agent. With the agent options and the actor and critic networks, you get the agent, and the agent options, of course, contains the parameters that we're going to play with. So now you have to create the training options, the final total time divided by total time of the step gives you the number of steps per episodes, maximum episodes, and you're gonna stop after 20 rewards going with 800 value. So that's just gonna be your stop criteria. But if you reach 200, you're gonna stop. So if we see an experiment reaching to 200, it means that it went out of limit and it just didn't work, that particular combination of hyperparameters. Okay, so we already got the logger, we have the agent, we have the environment, the training options, and the logger, so we can train it. And now this is the actual training. This is the step that takes most of the time. So once we finish, we have to pass to the experiment manager the agent that we created, the environment, and the result, and the parameters. And we're going to see that this object is created in the base workspace after we export it, after the experiment finishes. So let's go back to the experiment manager and let's see this running. When you run it, you can do it sequentially. That's gonna take a lot of time. You can use the cloud using batch, sequential, and simultaneous. But also you can use simultaneous if you have multi-core in your machine. In my case, I have 8, so it is gonna execute 8 experiments at the same time in my machine. You have to have the parallel computing toolbox for that. So let's run it, and it's gonna take a while to start. Okay, it started. You can see that we're gonna have 8 combinations, and you're gonna have the discount reward in here. So these are the different options. At the end, once it finishes, we should have the reward and compare which one gets us the best reward, and we're gonna see with the training plots how it looked during the training. Okay, finished. So let's take a look at the worst of them, which is the run number 4, and we can just get the training plot for it. So you cannot notice that it went all the way to 200. It didn't converge, so it reached the maximum number of episodes. So the reward was terrible. So the combination was a discount factor of 1, and basically both the biggest learning rate for both of them. So having high learning rate for both of them is not good. So the other ones, you can see most of them have a 800. So it seems that this is the worst combination for some reason. So when one has a low rate and the other one has a high rate, or vice versa, then everything goes well. Yeah, but that's not always the case, because in here you have the same combination for the both high rates, but you have a discounted factor, and in this case you got I don't know if this is some luck in here involved, but let's pick up the best performing one, this one, and you can see that it had the highest at 844 reward, but they finish in 70 steps. So let's pick up another one, the discounted reward. Let's say this one. So you can see that this finished a little bit earlier, and yeah, this one took a lot. This 833, actually this, I will say that this is the best. It didn't have the best reward, but it finished training in 35. And if you want to take these hyperparameters and have a big training with a lot of time, then you want to converge faster, so I will pick up this one. Let's go ahead and export it and use the name recommended by the article, which is this one. So let's just export it. It's gonna suggest a name. We're gonna put the name suggested by this article, and now we're gonna have that in the MATLAB workspace. So we're gonna sit in here and notice that in this script you return the agent, the environment, the results, and the parameters, which is the same thing that we get in here with this object. Okay, so let's just close that, and now let's go to the next experiment, which is for the environment. So let's go here. It's basically smaller. Basically, this is the reward for exceeding the bounds of the water tank, and also this is so it's a negative penalty. So if it is go out of bounds, you want to give a penalty to the agent. But if you're going in the desired direction, then you give a positive reward, but smaller, because it takes more steps to get into the right place. So yeah, so let's play with this. Let's take a look first at the script. We have to provide another script. This is just another experiment session, similar to the other one. From the perspective of the experiment manager, both of them are the same. It's just basically gonna sweep through all the possibilities, and as I mentioned before, since the possibilities in this case are 4 only, you can do exhaustive sweep, but also you can do Bayesian optimization in case that your state space is larger. Okay, so this is an entry point of the function, and again you have the parameters and the monitor. So it's gonna be the same. It's gonna be the same model. It's gonna be the same parameters in here, the same action observation. But what changes, also you create the agent, and you have to provide a reset function, and this is what changes. because previously in the previous reset function, we basically passed the handle to the function. In here we had to create a lambda because we're gonna pass the parameters to the function. So the input is always passed as always, but then we also pass the parameters. That's what varies in here. So notice that for the agent, we're not varying the parameter of the agent, so they are all constants, and all that remain the same. So let's go inside the reset function. So the reset function, as before, we're gonna have a random initial height of the water tank in here, and a initial condition, and a random reference value for the water tank level. So that's the same. What varies is that we're gonna pick up in the water tank, in the environment. Notice that this is the reward function. So this is the water tank. Again, if you get lost in here, I recommend going in the description of this video and watch the video on the reference about this Simulink environment for the water tank control. So that is gonna give in detail. So this is the reward function in here, and it's gonna pick up a couple of blocks, gain and gain 2. So this is going out of bounds, and this one is for when you go in the positive direction. When you're starting to fill the tank in the right direction. So it's gonna play with both of those values of the rewards and see what performs best. So you can see in here. Okay, so that's all that is doing. Okay, we going back to here. So we have the environment, which is what we are tuning this time. The agent, as mentioned before, we're not going to vary anything, so everything is constant this time. The learning rate and the discount factor is all constant. And then we using the same function, we create the critic and actor neural networks, and we pass it to the DDPG, deep deterministic policy gradient agent with the options. We get the agent, we have the environment and the agent. The training options are exactly the same. Again, the logger, we had to create a logger using the monitor of the experiment manager because the experiment manager is in control. So we pass the training option, the agent, the environment, and the logger, and we just train. And this is what takes the most time. Again, we return the same things. Okay, so let's go back there. Okay, now let's run the experiment. Again, you have the same options. We're gonna do simultaneous to run experiments in parallel, and it's gonna take a while to start. Actually, this started a little bit faster, and these are the 4 possibilities of reward, gain, and exceeding out of bounds. Okay, it hasn't finished yet, but you can see that a couple of them had a high reward and it already finished. So the parameters did very well for this reward because it finished fast, and these are not performing very well. So far the reward doesn't look good, and it seems that they're not converging. So in the end, this combination of parameters might be the desired one. But let's take a look at what happens at the end. Okay, the training finished. So as expected, these are the worst. Let's take a look at this one, the trailing. Yeah, you can see that the reward improved, but it took all the way to the limit of 200 episodes. So for this one, the best performing one is this one that got into the 800 reward in 35 steps, and this one a little bit lower. It took a lot more time to get into the 800 reward. So there's no doubt that this is the best performing one, which is a negative 100 reward for the out of bounds and a reward of 10 for the filling of the tank. So let's export it with the name that is suggested in here, which is this one. Let's just export it. It could be any name. But to go along with the example, we're gonna change the name to the one that they suggested, but it could be any. Okay, now we're gonna see again. We're gonna have this in the workspace. So now let's run the simulation. Now we have the agent and environment trained. So we're gonna try it in both ways. You can see each object is standalone, stands on its own. So this is the training for the agent, and we have for this object the agent and the environment and the simulation options, which is the one that we set in here. We're gonna simulate for 200 steps the episode, and of course we're gonna use the water tank, which is the environment, And yeah, so the agent and environment have a pointer to that particular model. So let's run it. But before running it, you notice that we have these scopes. So that's how we're gonna see that the water tank is filled or not. Okay, so let's just run it with the environment training. So it's supposed to finish. Let's see what happened. Oh, this is because I didn't run this. Okay, now I'm gonna run this again. Okay, yeah, of course I have to create this simulation options, and it's gonna finish soon. Yeah, so there it is. Notice that the initial height is 16 and the desired height is 12. So the flow is gonna basically is gonna drain the water tank level, so it gets into the desired position, and you can see that the flow affects that. It's negative at the beginning because you want to drain it, but when you're close to the goal, then it's gonna go positive until it gets to a steady state. And it seems that the water tank is draining, because otherwise when you get to the level it would be 0 at this point, but since it has a positive, it means that the water is draining at some rate. So you can see the rewarding here, maximum, because you reach your peak. So at the beginning it starts with a negative reward because you're not very far away from the water tank level. So the agent with the parameter that we tuned, it is working. So let's take a closer look at it. And you can see that we have the parameters. So let's take a look at the parameters. Notice here that when we select the best performing one, it's going to export the parameters that perform the best, and those are the parameters that are going to use for yeah. So those were the parameters that were used to train the agent. At this point, it's already trained. So we have the neural network of the critic and agent already trained. So those parameters are not taking any role in here in the simulation, but it's basically pointing you out the ones that work the best. So I, in theory, could take these parameters and do additional reinforcement learning training on the actor and critic to further improvement, now that I know that the best hyperparameter combination. So for the case of the environment, its parameters are different. It's regarding the rewards. And for this one, this should affect the simulation. So let's take a look at what happens in here when we run it. Okay, so again, it's gonna drain the tank to get into a steady state. We're gonna see the reward, and actually I don't know what's happening here. Let me take a look at the model. So I would like to see, we know that the desired parameters for this one are -100 and gain 10. So it's -100 for exceeding out of bounds. So that's what it's using for the reward at the very least. Okay, so let's just run it again. Okay, now it went in the opposite direction. So in here we have a negative reward because it's far again, and so it basically took you to the desired location. The previous one, it didn't for some reason. So yeah, so it basically filled the tank and stopped filling and went to steady state. So both of them are working. I don't know what happened with that glitch. Okay, that will be it. In this video you learn how to use the experiment manager to tune hyperparameters and select the best combination of hyperparameters for both the agent and the environment in a reinforcement learning training scheme. Okay, thank you very much.